Good morning, my YouTube viewers. Crystal here. I'm just here this morning because I wanted to make a video for you. I wanted to do another code review. Basically, this code review is going to be on the iris dataset. It's a very simple and easy dataset, but you have to start somewhere. So I thought, well, I'll do a code review on this dataset. The first thing I want to say is the iris dataset. It is very simple and easy. It's a very old dataset. I'm not sure exactly how old it is, but it's really old, and it's a simple dataset to work on. But what I will say is I made this dataset is actually loaded onto the sklearn website, so you don't have to go out looking for the data set because it's on the sklearn site already. But what I will say is this: I wrote my program on Google Colab, and Google Colab does not have the most current version of sklearn installed on it. The most current version is 24.1, and the version on Google Colab is, I think, 22. And so what you have to do is you have to go through and you have to install the most current version of sklearn onto Google Colab. I found that very disappointing that Google Colab is not keeping the most current version of the library on their platform, because the thing is that we have to use Google Colab. Well, we don't have to, but we choose to use Google Colab, and they should be putting the most current versions of their libraries on Google Colab, and they're not. I know if you look on my screen, you'll see that it says import sklearn, and it says the most current version is 24.1, but the reason why is because I went through and I installed the most current version of Google Colab onto it. But even after I had installed it, I still wasn't ready to make the changes. The reason why I wanted to have the most current version of Google Colab is because the iris dataset is actually on sklearn. And because the iris dataset is actually on sklearn, they've got a special hyperparameter when you load it called as frame. And if you go into as frame, then as frame will bring up an actual data frame. But that as frame hyperparameter is on version 24.1. It's not on version 22. And so I couldn't get the as frame to work on Google Colab because it didn't have the most current version. So that's one thing that's very disappointing. And the thing is that if you want to, if you install the most current version of Google Colab and you want to use it, then that means, every time you run Google Colab, you're going to be reinstalling this most current version. And then it tells you that you have to log off and log back on. And I thought, well, that's a lot of palapa. So rather than use the version that is actually on sklearn, which it's on sklearn, I decided that I'd go find an iris dataset somewhere and use it. And goodness me, I found an iris dataset somewhere, and I'm using that dataset rather than using the dataset that's on sklearn. But it would have been nice if I could have used the dataset on sklearn, because then I could have showed you how to do it. Now you can load up the dataset, but whenever you load up the dataset, it doesn't come up in a data frame format. And because it doesn't come up in a data frame format, you're not able to do a lot of work on the data set, which is what I like to do. So because of that, I just found a data set somewhere, and I'm using this data set that I found on the internet. So now that you know the background of the fact that Google Colab does not have the most current library of sklearn on it, you know that background. And even though you see that it says it's got version 24.1 on the screen, that's because I had previously installed it. But then it gives you instructions. It gives you instructions that you have to rerun the program and you have to reset the program. And I just thought, well, this is a lot of work to do. So I just decided I was going to abandon the project. Probably if Google Colab has a way, I can email him. I can send them an email and say, please, will you install the most current version of sklearn so I can use the asFrame hyperparameter. So on Google Colab, I've imported my libraries of pandas, NumPy, Matplotlib, PyPlot, and Seaborn. Pandas is written on the back of NumPy, and Seaborn is written on the back of Matplotlib. And then I also imported sklearn, and so you can see the most current version is 24.1, but I've already explained to you why that is. And then what we're going to do is we're going to read our file. Basically, I've got this iris data set off of somebody's GitHub account, and I borrowed it. And then so the file gives you an ID number, sepal length, sepal width, petal length, petal width, and then the species. So we check the information of the file. So the ID number is 64, and the float and the rest of the columns are floats. Now what we do is we do something called train describe, and that gives you the count, mean, standard deviation, min value, 25% value, 50% value, 75% value, and max value. So that gives you some important statistics that you're going to need, you might need. The next thing that I did was I checked for any null characters. There are not any null characters on this data set. Then what I did was I installed a heat map. So now you've got a heat map, so you can see how the independent variables interact with the target. And I noticed that I forgot to do a heat map on Boston house prices, which I should have done. That would have been interesting. Now we made a graph of the species, and so all three species are 50 each. So you can see all three species are 50 each. Now what we do is we have a box plot of the sepal length frequency, and then we've got the highest value is 5, and the lowest value is 7.1. That's the lowest frequency. We do a violin plot of the sepal width frequency. So the most frequent value is 5, and the least frequent value is 7.1. So that's a mistake right there. So I'll have to go through and correct that. So it's a good thing that I've made this video so I can go through and correct that. I was thinking to myself, well, that's not right. So what we'll do is we'll correct that when I finish this video. So so far I've found one correction that I need to make on this code review. And then what we do is we do the petal length video, and we do a violin plot for that, and the highest frequency is 1.5 and the lowest frequency is 1. So that's about right. The next thing we do is we do the petal width frequency, and the highest frequency is 0.2, 0.2, and the lowest frequency is 0.5. Now what we want to do is we want to ordinal encode the species. So we give Iris is setosa is 1, Iris versicolor is 2, and Iris virginica is 3. Next thing we do is we define our X and our Y values. So Y is trained species and X is trained dot species. But I'm going to go back and I'm going to take off the ID as well because the ID isn't necessary. But the model worked even though I hadn't taken off the ID. But you have to take the ID off as a matter of course. So now you can see the Y value, and the Y is 51s, 52s, and 53s, and it's not even scattered up. It's just all in sequential order. So it's a very easy data set to work with because of the way they did it. Now what we're going to do is we're going to make a 2D graph, which is very interesting. So we have to standard scale X to do that. We have to get the mean of X and then the standard deviation of X. And then we have to define some columns. And then we have to normalize the columns. And you normalize the columns by making a data frame of X and the columns. So now we're going to use the decomposition, the PCA, and we're going to use the PCA to make a 2D graph. And you can see the 2D graph. So you've got the 1s, 2s, and 3s, and they're all separate. And because they're all separate, it's very easy for the model to predict on them. The only one that's a little bit out of the way is this little yellow one here mixed in with the blues or the turquoise. Now we split X up for testing and validation. And I set it up for stratify as Y, random state is 1, shuffle is true. And then we check the shape. We select our model. And so we say C equals 10, and then we give you the kernel. So we make the kernel. And now what we're going to do is we're going to predict. So model 1 is logistic regression with penalty equals L1. It gave you an accuracy of 100%. We predicted on it. It gave us an accuracy of 100%. Model 2 is logistic regression with penalty equals L2. And it's a multinomial. And then you had to do a max iteration of 10,000 because if you didn't do a max iteration of 10,000, you would get a convergence warning. And it gave you a value of 100%. We predicted on it. It gave us 100%. Model 3 is logistic regression. Multi-class is one versus the rest. When we predicted on it, we got a 93%. So I thought, well, this looks good. Let's see if we can work with this one. So I created a confusion matrix, and you can see the confusion matrix. We had 5 of 0, and that was correct. 5 of 1, and that was correct. And we had 4 of 2, and that was not correct. And so you had 1 in there that was in the wrong placement. So now what we've done is we've made a 2D graph of the errors of the predictions, really. And so all of the predictions in purple is what they got correct, and this little prediction right here in yellow is the one that they got incorrect. So that's good. So we had 15 correct and 1 incorrect. So that was good. Now we do SVC is model 4. We got 100%, and when we predicted on it, we got 100%. And then Gaussian process classifier is was model 5. We got 100%, but we got a convergence warning as well. And when we predicted on it, we got 100% too. So this was a very simple and easy data set to work with. But since it comes with sklearn, I thought, well, I wanted to go ahead and do a code review on it to say what I've done in this code review, since it is one of sklearn's data sets. And I hope you like the video. If you like the video, please like, subscribe, and share. If you want to keep receiving the videos that I make, please press on the bell button beside the subscribe button, and you will receive a notification whenever I make a video. If you like the work I do and you want to support me, then I'm going to have my email address to my PayPal account in the description box down below, because I don't have enough subscribers, and the only way I can make any money on this channel is to ask for donations. And the thing is that I was just watching a video from somebody else, and they said that YouTube says if your channel doesn't grow, they're going to stop it. Well, obviously my channel is a really small channel, so I hope they don't stop my channel, because I really do enjoy making videos, even though I don't have very many subscribers. And you never know, maybe somebody will watch one of my videos and click onto the link and read one of my blog posts, which I do make money on the blog post. So thank you so much for watching this video. I look forward to making new videos for you in the future, and I hope you have a nice day.